Hello children, welcome to Math Park. Today we are going to solve second exercise, exercise 22B from class 9 ICSE topic trigonometrical ratios. Now this exercise has 30 questions. So we'll be doing in three parts. So today we'll be solving 10 questions in this. So children, if you like, please share with your friends and subscribe if you are new. So we start with the first question. From the following figure, find y sin x, sec x minus tan x and sec x plus tan x. So here, this is the acute angle x given to you. So we have to find y. So we'll be using by Pythagoras theorem. So by Pythagoras theorem, let us find this. Let us name it as A, B, C. Okay. So we have y is a perpendicular side. So hypotenuse is the side opposite to the right angle, which is AC. So we have BC, which is y is equal to square root of 2 square, that is hypotenuse square minus 1 square, which is 2 square is 4, 4 minus 1, which is root 3. So we got this y is equal to root 3. The first part is done. The secondly, we are asked to find sin x. Now sin x is equal to opposite upon hypotenuse. So opposite upon hypotenuse, so with respect to x, the opposite is y, so which is y upon 2, so which is root 3 upon 2 is the value of sin x. Next, we are asked to find this sec x plus minus tan x. So first, let us write the values of sec x and tan x. So sec is hypotenuse upon adjacent. So hypotenuse upon adjacent to x. So it is 2 upon 1. So it is 2. The value of sec x is 2. Then we have tan x is equal to opposite by adjacent. So it is y upon 1. So it is y upon 1. So y is root 3 and root 3 upon 1 is root 3. Now let us find the value of the third part of this. The first part was done here. This was your second part. Let us do the third part, which says sec x minus tan x. So sec x is 2 minus tan x is root 3 multiplied by sec x plus tan x, that is 2 plus root 3. Now this is in the form of a minus b into a plus b, which is a square minus b square. So 2 square is 4 and root 3 square is 3. So this is 4 minus 3, which is 1, is the value of sec x minus tan x into sec x plus tan x. Got it? Sin x was root 3 upon 2. Done with question 1. Question number 2, use the given figure to find sin x cos y, 3 tan x minus 2 tan y plus 4 cos y. Now here you are given 6. Let us name it the triangle over here. So if this is your A, this is your B and this is your C. So in this right triangle, and let this be D. So 6, 8, 10 is a Pythagorean triplet. So you can find this by Pythagorean. You get AD is equal to square root of 8 square plus 6 square, which is 8 square is 64 plus 36, which is root of 100, and that is equal to 10 centimeters. So we got AD as 10 now. Okay. Now you are asked to find sin x. So sin x is opposite upon hypotenuse. So straight away with respect to this thing, opposite with respect to x is, it is AB upon AC. So you have sin x is equal to, so this is how you get first part, that is sin x is equal to 8 upon 17. So first part is done. Secondly, you are asked to find cos y. So for cos y, we found this hypotenuse of this triangle ABD. So cos y is adjacent upon hypotenuse. So we have cos y is equal to 6 upon 10, which is equal to 3 by 5. Simplifying, dividing by 2. Now let us find 3 tan x minus 2 sin y plus 4 cos y. So for that, let us find the value of tan x first. So you have tan x is equal to opposite by adjacent. So for that, we need to find the value of BC. So let us find the value of BC by using Pythagoras theorem. So you have BC is equal to square root of AC square minus AB square, that is 17 square minus 8 square. 17 square is 289 minus 8 square is 64, which is root of 225, and that is 15. So you got BC as this, BC as 15. So therefore you get tan x is equal to opposite by adjacent, that is 8 upon 15 is the value of tan x, opposite by adjacent. with respect to x. Then you have sine y is equal to opposite by hypotenuse, which is sine y is 8 upon 10. So that is 8 upon 10, which is, we divide by 2, you get 4 upon 5. You got sine y. Then we want to have cos y, which we have already calculated. Now let us substitute the values over here in this. Let us start with the third part. 3 tan x. So 3 times 8 upon 15 minus 2 sine y. So sine y is 4 by 5. So 2 times 4 by 5 plus 4 cos y. So cos y is 3 by 5. So 4 times 3 by 5. So here first we simplify 3 ones are and 3 fives are 15. So we have now 8 by 5 minus 4 twos are 8 by 5 plus 4 threes are 12 by 5. So 8 by 5 got cancelled. We got the value of the third part is 12 by 5, which can be written as a mixed fraction. 5 twos are 10 and 10 plus 2, 12, 2 by 5. Okay. Question number 3. In a diagram given below, the triangle ABC is right angled at B. BD is perpendicular to AC. Find cos DBC. So we are concerned with this angle for cos DBC and cot DBA. So these are the two angles that we are concerned with. So these two right angles, when we are looking for, we just know this 5 and this is 12. We need to know the parts of this triangle. So first we find the hypotenuse AC. So we get AC is equal to 12 square root of 12 square plus 5 square, which is root of 144 plus 25, root 169, that is 13. So this is 13. So what we will do, if I take this as x, this will become 13 minus x. Now, since we have to find cos DBC, we need the adjacent side. So we will find now BD. So we'll use BD square is equal to, if I use this triangle, it is 5 square minus x square, which is 25 minus x square. Then we have another value for, if I use this triangle, then you get BD square. Here the hypotenuse is 12. So it is 12 square minus 13 minus x the whole square. So we have two values for BD. So we will be solving this simultaneously. So we can equate this from 1 and 2. We'll equate these values of 1 and 2. So if I take 12 square, that is 144 minus, I'll expand this 13 minus x the whole square, 169 minus 2, 3, 13 to the 26x plus x square, which is equal to 25 minus x square. Let us simplify this. 144 minus 169 plus 26x minus x square is equal to 25 minus x square. This minus x square will get cancelled. 144 minus 169 is minus 25. So 26x is equal to 25. This minus 25 goes here, becomes plus 25. So x is equal to 25 plus 25, that is 50 upon 26, which is 25 by 13. This is the value of x. We need to find the value of BD now. So we will be putting in many of the equations. We'll have BD is equal to square root of 25 minus 25 by 13 and the square of this. So let us take 25 common inside the bracket. So 25 in bracket 1 minus 25 upon 13 square was 169. So when we simplify this, you get it as, this is square root of 25 and 169 minus 25 is 144. 144 upon 169. So all of these are perfect squares. So when we take this out of the square root, you get BD is equal to 25 ka square root is 5 into 144 square root is 12 upon 169 ka square root is 13. So it is going to be 60 upon 30 is the value of BD. Now you are asked to find cos DBC. So first part, when we are finding cos of angle DBC, it is adjacent upon hypotenuse, that is BD divided by BC, adjacent upon hypotenuse. So which is 60 upon 13 divided by 5, which we get as 60 upon 13 into 1 by 5. This was 5 by 1, 5 ones are 5, 12s are. So which we get it as 12 upon 13. So this is how cos dBc we got 12 by 13. Let us find cot dBA 13. So let us find AD. So you have AD is equal to 13 minus 25 by 13, which we get it as 13. 13s are 169. 169 minus 25 is 144 upon 13 is the value of AD that we get. Now we are asked to find cot dBA. The second part, cot of dBA, cot of angle dBA is adjacent upon opposite. That is, with respect to this angle, the adjacent is BD divided by opposite, which is AD. So value of BD is 60 upon 13 divided by AD, which is 144 by 13. So let us simplify this. 60 upon 13. Put this becomes in multiplication. This is 13 upon 144. 13 and 13 got cancelled. 60 and 144 both are divisible by 12. 12 5s are 60 and 12. 12 to the 144. So we got the value of cot angle DBA as 5 upon 12. This is 5 upon 12. Got it? Angle ABC is right angled and this is AB is 4 and BC is 3. So we will have AC is equal to 5 centimeter. So we will take this as X, then this becomes 5 minus X. We are asked to find tan DBC, tan DBC. So we are concerned with this angle, and sine DBA. So we are concerned with another this angle. So we are looking for these two right triangles. For that, we will have to find the values of X and the values of BD. So let us use Pythagoras theorem and find the value of BD. So you have BD square is equal to the hypotenuse in this triangle is 4. So it is 4 square minus 5 minus X the whole square. So which is equal to 4 square is 16 minus this is 25 minus 10x plus x square. So when you simplify, it is 16 minus 25 plus 10x minus x square. And if I am using this triangle, you get BD square is equal to the hypotenuse is here 3. So 3 square minus x square. So which is 9 minus x square. We have two values. So let us equate this value. So we have again this is 16 minus 25 plus 10x minus x square is equal to 9 minus x square. This minus x square gets cancelled over here. 16 minus 25 is minus 9. So you get 10x is equal to 9 plus 9. So you get x is equal to 18 upon 10, which is equal to, if I take x is 8, it is 1.8, or you can take 9 upon 5 if I divide by 2. So I got the value of x as 9 upon 5. Now we will be finding BD. So you get BD is equal to 9 minus x square. That is BD square is 9 minus x square. So it is square root of 9 minus 9 upon 5 and then the square of that. So which is, if I take 9 common here, I get 1 minus 9 upon there were two 9s, 9 9s are 81. So, and 5 square, that is 25. So, which we get it as root of 9 and 25 minus 6, 9 is 16, 16 upon 25. So, all of these are perfect squares. So, when I'm taking this out, I'm getting the value of BD as 3 and 16 square is 4 and 5 square is 25 square is 5. So I'm getting this as 12 upon 5 is the value of BD. This is 12 upon 5 is the value of BD. Now we'll be finding tan DBC and sine DBA. So when we are finding tan DBC, so wherein you need opposite upon adjacent. So value of x is already we have calculated is 9 by 5. So tan DBC is going to be CD. It is going to be CD upon opposite upon BD. So you get tan DBC is equal to, I'm solving this part over here, which is equal to CD value is given as 9 upon 5 divided by BD, which is 12 by 5. So which we get as 9 upon 5 into 5 by 12. So which is 3 3s are 9, 3 4s are 12. We got this as 3 by 4. So we got the value of tan dBc as 3 by 4. D is equal to AD is equal to 5 minus X. That is 5 minus 9 by 5. 5 5s are 25. 25 minus 9 is 5 5s are 25. 25 minus 9 is 16 upon 5 is the value of AD. So we have to find the second part, that is sine of angle DBA is opposite by hypotenuse. So opposite to DBA is AD, which is AD divided by AD upon hypotenuse, which is AB. So this is AD is 16 upon 5 divided by AB, which is 4. So it is 16 upon 5 into 1 by 4. 4 ones are and 4 fours are. We get the value of sine of dBA as 4 by 5. So this is what you got this as 4 by 5. In triangle ABC, you are given AB is equal to AC is equal to 15 and BC is 18 centimeter. Find cos of angle ABC. Now this is not a right triangle, right? So it is not a right triangle because this is Pythagoras theorem is not satisfied here. 15, 15 and the base is 18. So here we will be drawing a perpendicular, and we know that in a isosceles triangle, the perpendicular is also and a perpendicular bisector. So this becomes 9 and this becomes 9. Now let us take this, the name of this triangle is ABC and let this be D. So you are asked to find cos of angle ABC. So cos ABC is equal to cos of ABC is equal to adjacent upon hypotenuse, that is simply 9 upon 15, which can be simplified as 3 3s are 9 and 3 5s are 15, and that's it. Question number 5 was the easiest one. Moving to question number 6. In the given figure below, ABC is an isosceles triangle with base BC is as 8 centimeter and AB and AC are 5 and 5. Find sine B. Now this is not a right triangle here. So again, we are going to draw a perpendicular over here. Let the perpendicular be AD. And in an isosceles triangle, the perpendicular is also the perpendicular bisector. So this becomes 4 and 4. So to find sine B, we need opposite side. So let us find AD. So you get AD is equal to square root of 5 square minus 4 square. That is root of 25 minus 16, which is root 9. And that is 3 centimeter is the length of AD. This is 3 centimeter. So sine B is equal to opposite upon hypotenuse, that is 3 upon 5. Then you have to find tan C. So tan C is opposite by adjacent. So it is going to be 3 by 4. Then you have sine square B plus cos square B. So sine square B plus cos square B is sine square B, it is 3 by 5 and then the square of that. And cos B is adjacent upon hypotenuse, that is 4 upon 5 and then the square of that. Let us simplify this over here. So 3 square is 9, 5 square is 25, 4 square is 16, 5 square is 25. So 9 plus 16 you get 25 by 25, which is equal to 1. So this is how we get sine square B plus cos square B as 1. Let us solve this part, that is tan C minus cot B. Tan C is opposite by adjacent, which we have already done here, which is 3 upon 4. And cot of B is adjacent upon opposite. So adjacent to B is 4 and opposite is 3. So it is 4 upon 3. So let us take the LCM of 4 and 3 is 12. So 12, so 3 3s are 9, minus 4 4s are 16. 9 minus 16, it is minus 7 upon 12. And we are done with question number 6. For question number 7, in the triangle ABC, and angle B is 90 degrees. So this is B is 90 degrees. This is your A and this is your C. You are given angle CAB is equal to X. So this is X given over here. Tan X is 3 by 4. So tan X is opposite by adjacent. So this is 3x and this is 4x. And BC is given as 15. Find the measures of AB and AC. So first thing, by Pythagoras theorem, you will have AC square is equal to AB square plus BC square. So AC is equal to square root of this. So which is 4x the whole square plus 3x the whole square. We know it is going to get 5. So it is 16x square plus 9x square. That is 25x square, and which is 5x. So we got this as 5x. But you are given BC is equal to 15. So BC is equal to 3x is equal to 15. So you get x is equal to 15 by 3, which is 5. So this is how you get AB. So AB is equal to 4x, that is 4 times 5, which is 20 centimeters. And AC is equal to 5x, that is 5 times 5, which is 25 centimeters. Got it? To find the value of sine phi and tan theta, write an expression for AD in terms of theta. So for sine phi, we need to find the opposite side, that is DC. So by Pythagoras theorem, let us find DC. DC is equal to square root of 13 square minus 12 square. That is root of 169 minus 144, which is root of 25, that is 5. So this is 5 now. So first part, the value of, and then you are asked to find tan theta. Okay. So for tan theta, we should have, this is not a right angle triangle. So we will be joining, we'll be dropping a perpendicular over here. So let it be, say, E. So you have BC is equal to DE. BC is equal to DE is equal to 12, because opposite sides of rectangle are equal. Same way you have EB is 5. So you have AE is equal to 14 minus 5, that is equal to 14 minus 5, which is 9. So you got this as 9 and this as 12. Now we will be finding the values of sine phi. So first question we start with. So sine phi is opposite upon hypotenuse. So opposite to this is 5 upon 13. Then second part you are asked to find, in the first part itself, the second is tan theta. So tan theta is opposite by adjacent, which is 12 upon 9. 12 upon 9 is 3 fours and 3 threes. So we got tan theta as 4 by 3. Right, the second part, it says write an expression for AD in terms of theta. So AD is an hypotenuse. So which ratios have hypotenuse over here? So, and opposite. So we have, we can write this as, take cosec theta is equal to hypotenuse upon opposite. So hypotenuse is AD upon 12. So you get AD is equal to 12 cosec theta. This is one value we got. So if I use sec theta, so sec theta is equal to hypotenuse upon adjacent. So which is going to be AD upon adjacent is 9. So you get AD is equal to 9 sec theta. So these are the two values we got in terms of theta for AD. Okay. Question B is 4 upon 5. So opposite, let us take this as 4x and this as 5x. Okay. Calculate the measures of AB and AC. So if this is 4x and 5x, so this BC is going to be 3x. We know that 3, 4, 5 is the Pythagorean triplet. So you have 3x is equal to 15. So x is equal to 15 by 3, which is 5. So this is how you get AB is equal to 5 times 5, that is 25 centimeter, and AC is equal to 4 times 5, which is 20 centimeter. We got this too. Now they say that the second part, tan ADC is equal to 1. So tan ADC is tan of angle ADC is equal to opposite by adjacent, that is 4x upon CD. So you get tan ADC is 1. So which is equal to 1. So 4x, this is already you have calculated this as AC as 20. So 20 upon CD is equal to 1. So you get CD is equal to 20. And AD now we find by Pythagoras theorem. So we have AD is equal to square root of 20 square plus 20 square. These both sides are 20 and 20. So which we get it as root of 400 plus 400. So which we can write as 400 into 2, which is 20 root 2. Now we have asked to show that tan square b minus 1 upon cos square b is equal to minus 1. So tan b, what is the value of tan b? So we have tan b is equal to opposite by adjacent, that is 20 by 15, which is 4 upon 3. Then cos b is equal to, cos b is adjacent upon hypotenuse, that is 15 upon 25, which is equal to 3 by 5. Now we have to find the value of this. So let us take LHS, that is tan square b minus 1 upon cos square b, which is equal to tan square b is 4 upon 3 and then the square of that, and 1 upon cos square b. So we'll take the reciprocal of this. So we have 5 upon 3 and then the square of that. So 4 square is 16 upon 9 minus 5 square is 25 upon 9. So which we get it as minus 9 upon 9, that is minus 1, and that is our RHS. So hence proved that tan square b minus 1 upon cos square b is equal to minus 1. Question number 10, if sin A plus cosec A is equal to 2, find the values of this. So we are given sin A plus cosec A is equal to 2. So let us square both sides. On squaring both sides, we get sin square A plus cosec square is equal to 2 square. A plus B the whole square, that is sin square A plus cosec square A, that is A square plus B square, plus 2 sin A cosec A. 2 sin A cosec A is equal to 2 square, which is 4. Now sine and cosec are reciprocal. So we have sin A into cosec A is equal to 1, since they are reciprocals of each other. So this is how we get sin square A plus cosec square A plus 2 is equal to 4. So we get sin square A plus cosec square A is equal to, this 2 goes here, 4 minus 2, which is 2. Got it? So children, we are done with the first part. We will be coming up with the next questions of this exercise. So if you like the video, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching.